Alright, today what I'm going to do is I'm going to do some practice for grade 11, the Unit 5 Trig 1 unit, and what I'm going to do is I'm going to find the exact values of trig ratios, I'm going to find equivalent angles, I'm going to use sine law, cosine law, and I'm going to talk about the ambiguous case. So, find the exact values of each trig ratios below. Step 1 in this process is to draw special triangles and step 2, draw the arm. What that means is basically if I had an angle of 135, where would the arm go? And then step 3, get acute angle. What that means is you're going to take the end of the arm and you're going to draw a line down. So, for example, here's the arm. It's in the second quadrant. I'm going to draw the arm down and I'm going to determine what goes there. Okay, so it's the acute angle. Step 4, get ratio. So get the answer, basically. Okay, so here we go. Cosine 135. 135 would mean I am in the second quadrant. Also, the angle here is 45 degrees. Now, I've got two possible special triangles that I really worry about. One is the ones with 45, okay, and the two side lengths are just root 2 over 2, root 2 over 2, and 1. Okay, there's this other version that has 1 root 2. I don't personally bother with that because what you have to do is you have to rationalize your final answer anyway. So I avoid that triangle altogether like the plague. And I've got this triangle here that I need to worry about. Now the other triangle has 30, 60, and the two ratios are 1 over 2, root 3 over 2, and 1. So it's 1 over 2, root 3 over 2, and 1. So yeah, I have an angle of 45. In my triangle, the ratio that's adjacent to that is root 2 over 2. So guess where root 2 over 2 goes? Right there. Now, what would be the sign on this? Well, I'm in the second quadrant, so I've got a negative. The radius is 1, and I also have to note the following. Cosine theta, and I want you to write this down on your tests. Cosine theta is x over r, sine theta is equal to y over r, and tan theta is equal to y over x. So cosine theta is just going to be negative root 2 over 2 over 1, which can be just simplified to negative root 2 over 2. Done. Now, tan of 240 has more to do with what we just talked about, the special angles. We'll jump to 270 later, but let's do tan of 240. Where is 240? Well, 240 is in the third quadrant, and if I draw a line to the x-axis, which is something I'll always be doing, the angle in here would be 60 degrees, because this thing is 180, and if I add 60 to that, I get 240. So what would the trig ratios be for 60 degrees? Well, if you notice, I have to look at the adjacent side and the opposite side. So the opposite side, the side furthest away from 60, is root 3 over 2. So this side here would be a negative root 3 over 2 because I'm in the negative y values. Over here, the adjacent side should be a 1 over 2, but more specifically, it should be a negative 1 over 2. And if tan theta is equal to y over x, then it's just going to be negative root 3 over 2 divided by negative 1 over 2, which can be simplified to root 3, because the negatives cancel, and so do the 2's. and so I get root 3 over 1, which is equal to root 3. Now, what about this funny angle? And these are the funny angles I want you to worry about. 0, theta equals 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360. Be careful of these. These have nothing to do with your special angles. They are special in a way, but they have nothing to do with the special triangles that we just drew. So at 270, my line goes straight down. And the coordinates of this point are actually 0 and -1. So y is going to be -1. R will always be 1 in this case for the unit circle. So sine theta, sine 270, is -1 for y over 1. So this is y, and this is r, y over r. That can just be reduced to -1. So my answer is -1. That's it. So that's part 1. That was a little bit much, but I promise you once you practice, it should be fine. Number 2, step 1 in this process is to draw cast, or all snow tastes cold. Okay, what this means is cosine is positive, all are positive, sine is positive, and tan is positive. They go in the following format: C, A, S, T. Okay, step 2, draw the arm and determine where your trig ratio will have the same sign. Draw the arm, and after you draw the arm, draw a line to the x-axis, determine the acute angle, and you're good to go. So let's try that in practice here. Where would 150 go? Well, 150 is in the second quadrant. What would be the related acute angle? To the x-axis, this angle would be 30 degrees. Sorry, that looked like 36. So that's 30 degrees. Now, what is the trig ratio for tan? Is it negative or positive in that quadrant? Well, the only trig ratio that's positive in that quadrant is sine, so the tan ratio will be negative. Where else can I get a tan ratio that's negative? Not here, because that means positive tan, and not here, because that means positive all. So I'm going to have it over there. And if I draw the same acute angle, then basically my angle is going to be, my related angle is going to be theta equals 360 minus 30. So it's going to be 330 degrees. Therefore, my final statement is the following. Tan of 150 is equal to tan of the angle 330. Please do check this in your calculator, by the way. Tan of 150 should be equal to tan of 330. You do both sides. If you get left side equals right side, you're good to go. You can also do the same thing here, by the way. If you punch in cos 135, making sure that your angle is in degrees, you should get the same answer as if you punched in negative root 2 over 2. So check that left side equals right side. Please, oh please do that. 285, where is that? Well, all I have to do is find where my arm 285 is. Well, it is 15 degrees past this line. That line is 270, right? So if I draw my terminal arm, what that means is this is going to be 15 degrees. So this is going to be 75 degrees. Okay, so I'm going to erase this part. So my arm has an acute angle of 75 degrees. Now, what is cosine's sign here? Well, it's positive because of that statement right there. So where else am I going to get a cosine that's positive? Well, it's going to happen at all. So I draw a line, and it's going to have the same trig ratio. And I need to determine this angle. Well, the angle is very easy. Because it's in the first quadrant, theta is equal to 75 degrees. Therefore, what I can say is cosine of 285 is equal to cosine of 75. And once again, what I want you to do is check your statement. Now, what is one positive and one negative coterminal angle? So the theta that's positive is going to be negative 157 plus 360 degrees. The theta that's negative means I take that angle and I subtract 360 degrees. Okay, so the only thing that determines a theta positive and a theta negative here is the sign in the middle. What you do with the 360, do you add it or subtract it? Right? So that's the only difference. So once you find out these two values, what's that one and what's that one, you're done. It's a quick one-stepper. Now, find the exact values of the three primary trig ratios. What you're looking for is determining what x, y, and r are for this angle. So you need x over r for cos, you need y over r for sine, and you need y over x for tan. So, where would negative 600 and negative 765 degrees go? Where would the arm go? Well, what you need to do is you need to know that that says negative 765. A negative means I actually go clockwise, not counterclockwise, clockwise. So here's what I'm going to do. I'm going to draw an angle that is negative 765. Here we go. One full rotation is 360. A second rotation is 730. And then how do I get negative 765? Well, I go 35 degrees below the horizontal. So what that means is the related acute angle is just 35 degrees. Does that make sense? So you go clockwise, one rotation, that's 360, two rotations, 730, and then I go 35 degrees to get the full negative 765. So if my angle is 35 degrees, then I can determine what x and y and r are. The only problem is this isn't a special angle. So why don't we go back a bit? Why don't I erase this? The same idea follows. Sorry to confuse you, but I can't really use my special angles there. So why don't we pick a different angle that allows me to use my special angles? So instead of 765, what I could do is I can go 765. What I could do is I could go 775. Okay, which means I would still go a full, two rotations, but that acute angle changes so that I can use special angles. Remember that. Okay, so you should be able to use special angles here. So here we go. Let's try that again. So I go clockwise, 360, clockwise, 730, and then to get to 775, my related acute angle would be 45. So now I should be able to use the special angles, or the special triangles. So for 45, it was root 2 over 2, root 2 over 2, and it was 1. So what side is adjacent to 45 degrees? Well, it is root 2 over 2. So root 2 over 2 should go here. What about for y? Well, the side opposite 45 is root 2 over 2. And this is 1. So now I have x, I have y, and I have r. So I can determine cosine theta, sine theta, and tan theta. So cos theta is going to be x, which is root 2 over 2. Oh, by the way, this y coordinate is not positive, it is negative because I'm in the negative quadrant. Okay, so this should really say negative root 2 over 2. I apologize. Conversely, the x is positive x, so that is a positive root 2 over 2. Okay, so root 2 over 2 over 1, which is root 2 over 2. Sine theta is going to be y over r, which is negative root 2 over 1, which is negative root 2 over 2. And tan theta is going to be negative root 2 over 2, which is y over root 2 over 2, which reduces to negative 1. So that's it. Tan, cos, and sine. Now, sine theta, and I apologize for this, what I mean to say is sine theta is equal to 12 over 37. Okay, now sine theta is y over r. So the numerator is y, and the denominator is r. And it wants the exact values of cosine theta, which is x over r, and it wants y over x. What you need to determine, guys, is you need to determine x, y, and r, and then just determine the ratios. Just punch them into the formulas for cosine theta and tan theta. That's it. So let's see. What is the formula? Is there a formula that relates x, y, and r? There is. It's the area of a circle, or the equation of a circle. So it's x squared plus y squared equals r squared. Okay, now I can isolate for x. How do I do that? Well, I have y and I have r. So basically, y is 12, so y squared is that, and then r squared is 37 squared, and then I can determine x squared by isolating. So all I have to do is isolate for x. Once I do that, what do I get? Let's see. 37 times 37 is 1369. And then 12 squared is 144. And once I square root that, what do I get? I get a magnitude of 35. But I want you to remember something. It says quadrant 2. So if I'm in quadrant 2, right here, do I have negative x values or positive x values? I have negative x. So really, this should actually say negative 35. So you have to be careful. Okay? So this is extremely important. So what would cosine theta look like? Well, cosine theta is x over r, and I found x to be negative 35. So this is cosine theta. This is x, this is r, and I don't have to reduce. Great. Sine theta is already determined, so I need tan theta. Tan theta is just going to be y over x. Y is 12, and x is negative 35. Please do not leave the negative in the denominator. Shift it to the top. Okay? And that's it. Basically, that's cosine of tan. Easy as pie. Okay, solve the following equation for theta between 0 and 360. Okay, step 1, when you have a quadratic equation, okay, step 1 is substitute a letter, a variable, for the ratio. What that means is switch tan theta in this case with some variable. In this case, I'm just going to choose w or something like that. W squared minus 1 equals 0. I'm going to avoid using x, y, or r, or any of those letters because we have already used them in the past. I'm just going to choose a different letter. So if I want to isolate for w here, I can either factor or I can move 1 to the other side. Now, I'm going to opt to try to factor this. This is a difference of squares, so I can square root this, and I could square root the last term, and my two brackets are going to be w minus 1 and w plus 1. So what I end up getting is a w equal to 1 and a w equal to negative 1. But what did I substitute for w? Well, tan theta is equal to w, so tan theta equals 1, and tan theta equals to negative 1. Now, what you also have to remember is that tan theta is y over x. Okay, so tan theta with the y over x is equal to 1, and tan theta y over x equals to negative 1. So I always have a denominator under any whole number. So the denominators here are 1 and negative 1, or excuse me, 1 and 1. So now, how do I determine what the angles are? Well, I need a tan ratio that gives me 1 and negative 1. So first of all, I'll draw the arms. Where am I going to get a tan ratio that is positive? So let's do the star first. Positive. Well, I can get a tan ratio that's positive in this quadrant, and I can get a tan ratio that's positive in the opposite quadrant, okay, because of CAST. So I need to determine what this theta is and what that theta is. Well, I'll give you a hint. These are my special angles, okay? But if I don't know what they are, no problem. What you can actually do is you can punch in 1 into your calculator and then do inverse tan. So if you do inverse tan on, or second tan on 1, the acute angle is actually 45 degrees. And this is for tan theta equals 1, by the way. Okay, and the acute angle here is also 45 then, right? So my two angles are 45 and 180 plus 45. 180 plus 45 is 225, and then this theta here is equal to 45. So for tan theta equals 1, theta equals 45, and theta equals 225. Okay, now what about tan theta equals negative 1? For tan theta equals negative 1, I do the same thing. I draw my coordinate axis. How do I get tan theta to be negative? Well, tan theta can be negative in these two quadrants, the opposite two quadrants. Okay, because I know that C is the only one positive there, A is the only one positive, all are positive there, sine is the only one positive there, and tan is the only one positive there. So the places where tan is negative is right there. Now what would be the acute angle for negative 1? What you do is you take away the negative, and then you do inverse tan on 1. We already did that in the previous example. So the acute angles are 45 and 45. So all I have to do is draw a line to get my angles. That's 135, and that is equal to 360 minus 45, which is 315. So for tan theta equals negative 1, my two angles are equal to 135 and 315 degrees. So that's how I'd solve that equation. So the solution is equal to 45. So I would write down all the angles in order: 45, 135, 225, and 315 degrees. Done. Those are my angles. Now this is where we use cosine and sine law. So a triangular glacier has side lengths I equals to 43, C equals to 90, and E equals 51. Solve for the largest angle. Step 1, guys, is draw the triangle. Okay, so I'm going to draw this triangle, and it has coordinates, or axes, excuse me, it has vertices ICE. So I'm going to draw that out. ICE. I always struggle with drawing triangles. Okay, I, C, E. Okay, just a random triangle. It gives you the side lengths, little I, little c, little e. So what are they? Well, opposite big C is little c, which is 90. Okay, that's right there. Opposite capital I is little I, 43. And opposite capital E is little e, 51. Now we are tasked with solving for the largest angle. You should be able to tell me what the largest angle would be in this case. The angle that's largest is opposite the largest side because it'll open the most. So really, we're looking for angle C. So I have to set up cosine law to solve for angle C. Here's how I would do that. I would set up the equation, and I would have the equation to isolate for capital C. There are actually two ways to do this. One way is to use the original cosine law formula, which would be little c squared equals I squared plus E squared minus 2EI cosine capital C. The other way is to use the formula where cosine C is already isolated for. So cosine C would actually equal to C squared minus I squared minus E squared over negative 2EI. This is basically the formula that I recommend you use because it's just plug and play. So cosine C is equal to, and then I just plug in information, 90 squared minus 43 squared minus 51 squared all over negative 2. 51 times 43, and then I do inverse cos on that, and I end up getting an angle. Okay, I think the angle should be, I don't know, around 100 and something, but double check. So that's how you'd solve for the largest angle. It's just using cosine law. Next, you are stringing a set of holiday lights around a triangular courtyard KSI. The dimensions of the courtyard are shown below. They're not. I literally wrote them down here. But the triangle KSI, okay, will have KSI as vertices, and little I is 52, little s is 46, and there's one angle that's given. So if I go back, I have to determine what the angle was. So if I go back here, and I look it up, so the angle is 65 around angle I. Okay, so the angle is 65. Okay, so for angle I, the angle is 65 degrees. So how long is the indicated side little k? We have to determine angle k, or side length k. Now, I want you to remember something. If you can use sine law and two sides plus one angle is given, this is ambiguous case. Okay, so if you can use sine law, which I can because I have a side length opposite an angle, and two side lengths are given, this is ambiguous case. So how do I set this up? Use sine law to find one of the angles. That would be my recommendation. The only angle you can really find here is S because I have a side length opposite that. So here's what I do. Watch. I go sine S over 46 equals sine 65 over 52. So I've set up sine law. And what I'm going to do is I'm going to move 46 over by multiplying. and I get 46 sine 65 equal over 52. I will get sine s equals to the following. So I'm going to punch this into my calculator, so give me a second. So sine s is approximately equal to 0.802. Okay, sine s is approximately equal to that. Once I reach this stage, so step 1, or in this case, step 2, is to set up sine law. Here's step 3. Watch this. Step 3 is to perform a split. Okay, so step 3 is I'm going to do two things. First is I'm going to do inverse. So S, my angle S, is going to be inverse sine on 0.802. That'll give me one option for angle S. Okay, so if you do that, if you do inverse sine on 0.802, I must be in radians. I swear to God, I should be in radians right now. I'm probably in radians. Okay, why don't we do this? Why don't we go to Google and type this into our calculator over 55, and this is in degrees divided by 52. You do get that. Okay, very good. And then if you do inverse sine, which is arc sine, you get that many rads in degrees. What does that turn into? 53.3 degrees. Okay. So for this case, what I end up getting is 53.3 degrees. Okay, so that's capital S. Now the second option, so this is S1, right? The second option would be 180 take away 53.3. Always 180 take away your first answer. Okay, so it's always going to be 180 take away the first possible angle. So 180 take away 53.3, okay, is going to be 180 minus 53.3 is going to be 126.7 degrees. Okay, now I found two angles for S. So if I found two possible angles for S, guess what? There are two possible angles for K. So I need to find K1 and K2. Here's how I do that. I subtract from 180. I subtract angle I, which is 65, but I also subtract S1, which is 53.3. What do I get? 180 minus 65 minus 53.3 is 61.7. Let me double check that. 61.7 degrees. What about K2? I do the same process. 180 take away I, take away S2, which in this case is 126.7. What do I get? Ooh, I get a negative 11.7 degrees. That's impossible. You cannot have one of the angles negative inside of a triangle. So what you say is this triangle is not possible. So there's only one possible answer for S and K. So angle S is 53.3 and angle K is 61.7. So here's my possible triangle. This is going to be still 65. So this is I, this was K, and that was S. So this is 53.3. This has to be 61.7. And my side lengths are 52 and 46. And now I can set this up to find little k. So how do I do that? Well, I can use sine law, right? So little k over sine 61.7 is going to be equal to 46 over sine 53.3. And so k is going to be 46 sine 61.7 over sine 53.3. And then I could just punch that into my calculator. Now, I'm going to trust Google in this case, and I'm going to try to punch that in. So 43.3 degrees, I get 50.5, and the units are 50.5. The units for this are in feet. Now, how many total feet of holiday lights do you need? Well, I've got now a triangular courtyard that needs to be filled all around the outside, right? So all you do is you add them all up. 46, what was it, 50.5 and 52. So I find basically the perimeter, which is the sum of all the sides. That's what this means. This means find the sum of all the sides. So you just go 52 plus 46 plus 50.5, all in feet, and then I find the total. So then 52 plus 46 plus 50.5 is 148.5 feet, approximately. Okay, so that's basically it. That's the practice for this trig test. So hopefully this was helpful, and I'll see you in the next one. Love you. Bye.